It is your host with the most, Master Yoda, PhD. Today, we'll learn about many things regarding gases, their characteristics, behaviors, laws, and their formulas.
Sir, how interesting!
Oh, how are we going to start off?
We start off with the characteristic of gases. Firstly, gases are fluids.
Fluid? Like H2O?
They are fluids, like water, because they can flow since their particles are far apart. They're far apart, which also gives them low density. As most of it is filled with empty space, they also completely fill every corner of their container.
Master Yoda, does that mean that gases are everywhere?
Master, gas particles move under high speeds and don't attract each other much. Therefore, they expand to fill their container. Finally, they are highly compressible, which means that by applying pressure, you can reduce their volume.
Wait, Master Yoda, what is pressure?
As shown, pressure is force divided by area. Let me enlighten your young minds with this example. Let us represent this fine needle with a car engine cylinder. As the cylinder volume decreases, there are more molecular collisions, and as the pressure of the gas increases, between particles, more pressure. And this represents our first gas law, Boyle's law.
Is that when you boil an egg?
And a hard egg comes out?
Oh, just because it rhymes with boil, it doesn't mean you're boiling stuff. The inverse relationship between pressure and volume is known as the Boyle's law. Here is an example my helper Amalia and Thais will show.
As you see, when P goes up, V goes down. And when V goes up, P goes down. But the constant always stays the same.
That is the relationship between gas laws.
Remember, and there's also Charles' law.
We learned it yesterday. It describes the relationships between volume of a gas and temperature. This is an example of Charles' law. When the temperature of the air inside the balloon decreases, the volume of the balloon decreases.
And when we come back in 10 minutes, the balloon will basically be smaller.
As you can see, the volume of the balloon decreased as the temperature decreased. Charles' law.
Charles stated that the volume of a gas increases as the temperature increases, and the volume of a gas decreases as the temperature decreases.
If all the other conditions are kept the same, the constant V divided by T will remain the same. Therefore, V, the initial volume divided by the initial temperature will equal to the final volume divided by the final temperature.
But make sure the temperature is in kelvins first, otherwise you won't get the right results.
What from you learned yesterday, can you tell me the two remaining laws? Two remaining laws are the Gay-Lussac law and the Avogadro law. Please tell them to me.
Avogadro stated that the volume divided by the number of moles equals a constant, as long as temperature and pressure remain the same.
In addition, Gay-Lussac said that pressure divided by temperature equals a constant.
I see you learned a lot you have, but what do all these gas laws have in common? Let me tell you. They create the ideal gas laws.
Gas law is the most important one of all of these laws. It relates all the equations and merges them into one huge equation.
This is it. PV equals nRT. Pressure times volume equal to number of moles times constant times temperature.
That will help everyone understand.
That's right, young master. Enlighten us with your ideas. In this ideal gas law, where PV equals nRT, R, which is a constant, equals 8.314 liters times kilopascal over mole over times K. How many moles of gas are contained in 22.41 liters at 101.325 kilopascals at 0 degrees Celsius? First, we're going to start off replacing the variables, where v equals 22.41, p equals 101.325, t equals 0, and n, which is number in moles, equals the variable. We have to convert the temperature into Kelvins, which is 0 plus 273, which is Kelvin value, equals 273 Kelvin.
Plug in the values into the formula.
Solving for n, we get an amount of 1 mole. Now I will show you a real life example. We know all the bits of ideal gas laws. Let's have a real life example. This will represent the equation. Always keep it safe. Put a bit of water into the soda can and let it boil. The vapor particles inside will be crazy, and once it's released, it will crush itself. Looking at the formula, R doesn't change since it's constant. Temperature drops insanely when I drop the can in the cold water. In addition, pressure decreases because temperature decreases, and the volume decreases as well. And the pressure outside the can is so dense, it crushes a can. Now we finish explaining, we have to go to the most important questions in our life. How do we show that gas has mass and density?
Our answer is yes. Gas has mass and density. However, you should know that gas is a state of matter, just as solid and liquid are.
All matter is made up of particles with a certain mass. Since gas.
So we have torqued out both balloons, the yellow one with more gas and the pink one with less gas. It's evident that we can see how the yellow balloon has more gas, therefore more mass because of the particles. And we can see it by balancing it out. Yeah. Gases do have density, like other objects in the world, but it has low density since their particles are in random motion and they're far apart. So, summing it up, they do have density, but it's low density. Ow. Goodbye, and may the force be with you. I'm not Yoda, I'm a dog. So, bye.